This will be our last lesson for this topic. We are not doing topic 23. So this is 8th grade, module 7 for lesson 22 on average rate of change. All right, so we have this cone here. The height of the container is the shape of a circular cone is 7.5 feet. And the radius of the base is 3 feet, as shown. What is the volume of the cone? So we've been practicing with volume of a cone, so I'm going to let you go ahead and work this one out. I'll write it out for you, though. Volume equals 1/3 pi r squared h. And now your r squared is going to be 3 squared, obviously, and your h is going to be 7.5. So go ahead and get that answer, and then I'll help you fill in the rest of this problem. All right, now we are going to fill this container up. So before this, we watched a YouTube video. I'm going to go ahead and write the YouTube video that we watched in class. The web address here is youtube.com/watch with a question mark, lowercase v, equals capital V, capital E, lowercase f, capital H, capital J, capital H, capital M, capital Q, capital S, and then 8. So watch that video because what I'm about to tell you comes from that video. So they're filling this cone up with sand. And obviously we're filling it up at a constant rate. So we're not going fast and then slow and then fast again. It's just a very steady rate. The rate is being filled at 6 feet cubed, or 6 cubic feet in 1 minute. So they want to know how long will it take to fill up this cone. So we're going to take our volume of 22.5 pi over 6, divided out of 6. Okay, so 6 goes into this, and I wind up with 3.75 pi. Now let's multiply this by 3.14. And that's going to give me 11.775. We can say about 12 minutes. I would say go ahead and round that up to 12 minutes. It would take about 12 minutes to fill this up with some sand. All right, now to fill it up into 1 foot, what would that look like per foot? So I'm going to move this up just a little bit, give myself some more room here. So we're going to say to find, I read sand, but I guess it's water, whatever. We're filling the cone up with something here. So I just looked down and I saw the word water written on my notes. So to find water at 1 foot. So how long does it take it to get to 1 foot? Because if you notice, we're going to start to fill this out for the chart next to this problem here. So I'm going to set this up. We're going to say it takes the radius of 3 over the radius of x. Now this right here is x, because I don't know what the radius is there for this part here at 1 foot. I don't know, so I'm going to call it x. So we're going to say 3 over x is equal to 7.5, which is my height over here, to 1, which is my height down here. Cross multiply these, and I wind up with 7.5x equals 3. I'm going to divide out the 7.5. And I get x equals 0.4. So I'm going to take my volume formula. Volume equals 1/3 pi r squared h. I'm going to say 1/3 pi times 0.4 squared times 1. So that's going to give me 1/3 pi times 16 times 1. Which is basically 16. So that's going to give me, oops, forgot my decimal there, 0.16. 0.16 over 3 pi. When I multiply that out by pi, I'm going to get 0.167. Now, I'm going to divide this by the rate. If you remember, the rate was 3 cubic feet per minute. So I'm going to divide this by 6. Sorry, not 3. It's 6 cubic feet by 1 minute. Divide this by 6 and I get 0.028. So on the chart on the next side, for 1 foot, it's going to take 0.028 of a minute to fill that up. So you're going to continue doing the same thing we just did there, but for each foot. So what you're basically changing, instead of 3 over x equals 7.5 over 1, I'm going to put 7.5 over 2, and then 7.5 over 3, 7.5 over 4. Same sort of thing. Use 3.14 for the pi. And then you're going to come down, you're going to take all those values and you're going to graph it. So if I were to graph my first one, I'm going to go up to 1 because the water level's at 1 and it's at 0.028. That's almost like right there on it. It's very close. Now, of course, you're going to have to guess on some of these. It's not going to come out perfectly. And do expect that it's going to kind of be like a gradual. It's not going to be a straight linear equation. It's going to be gradual, and that's because we're dealing with pi and estimated values here. All right, so that ends this video tutorial. This will be one that I grade. Now in class, my students will be working with partners on this, so if you get stuck, you're more than welcome to work with a partner on it as well. Thank you, and this ends this tutorial.